Hello and welcome to COM 3026 Distributed Systems. In this lecture we will discuss total order or atomic broadcast. To recap, in the previous lectures we discussed various kinds of reliable broadcast, and in particular reliable broadcast does not impose any ordering guarantees on the message delivery, and processes are free to deliver messages in any order they wish. So in contrast, causal and FIFO broadcasts do impose ordering constraints on the message delivery, and so processes need to deliver messages according to some order. So we considered two types of order in this context, such as FIFO ordering and causal ordering. However, the order imposed by causal or FIFO broadcast is partial. Okay, that means that different processes may deliver some messages in different order. Okay, so some messages are left unordered by this type of ordering constraints, such as causal ordering or FIFO ordering. So let's see a few examples. So in this example, we're just looking at a reliable broadcast. So here we have some ordering constraints between M1 and M2. So M1 is sent before M2 by process P1. However, since we are talking about reliable broadcast, the processes are free to deliver these two messages as well as other messages such as M3 here in any order they wish, right? And in particular, we can see that P1 delivers them in the order M1, M2, and then M3, and P2 first delivers M3 and then M1 and after that M2, and finally P3 delivers M3, M2, and M1. So in particular, the delivery order at P3 violates the FIFO or causal order in this case. Okay, so it is a reliable broadcast, no guarantees whatsoever on message ordering. But as we discussed, even if we have a stronger requirements with respect to message ordering, some messages still remain unordered. So in this example, if we have causal broadcast, but that also applies to FIFO broadcast in this case, because the process ordering is one of the constraints of causality between messages. So here we have M1 causally precedes M2, and indeed with the causal broadcast we have that M1 is delivered before M2 everywhere. But still, M3 is concurrent to both M1 and M2. There is no causal dependency between M3 and either M1 or M2. And for that reason, causal broadcast does not restrict its delivery order relative to the two other messages. And indeed what happens that P1 delivers M3 after M1 and M2, and P2 delivers M3 before M1 and M2, and the same applies to P3 as well. So total order or atomic broadcast takes care of this deficiency or limitation, if you want, and it requires that the delivery order at all processes must now comply with the same global order. That means that message ordering now becomes total ordering. Okay? So it's not partial anymore, it is total now. So notice that there is no specific requirement that this order respects either causality or FIFO ordering among messages. So it does not need to respect any extra ordering constraints. However, it must be noted that total order broadcast can be made to respect extra ordering constraints such as causality or FIFO. And as we discussed in the previous lectures, this is often useful in practice, right? So remember the chat service implemented using broadcast. However, to simplify presentation in this lecture, we won't impose any extra ordering constraints. So we will just care about total ordering, or total order delivery of messages. So let's see a few examples. So in this example, we have a total order that doesn't respect causality. So we have the same situation. Process P1 sends M1 and then M2, and then M3, P3 sends message M3 concurrently to M1 and M2. And in this example, everyone delivers the messages in the same order, which is M2, then M1, and then M3. Okay. However, this order doesn't respect causality, because according to the causal delivery requirements, M1 must be delivered before M2 because they're causally dependent, but this order is violated. So M2 is delivered before M1 at all processes. So in this slide, we have a total order broadcast that does respect causality. So again, it's just the same three broadcast events occur, and then the delivery order is M1, M2, M3 everywhere. Okay. So that means that this order is total order, and it also respects causality, because M1 causally precedes M2. It must be delivered before M2 at all processes, and this is indeed the case in this example.